If your exams are near and you are scrolling for the rapid revision, then this video might be beneficial for you. Let's start our Chapter 1 of Class 11th, that is some basic concepts of chemistry. First of all, what is chemistry? Chemistry is the branch of science that studies matter, its properties, composition, structure, and the changes it undergoes. In simple words, chemistry helps us understand everything around us, what substances are made of, how they behave, and how they change during different reactions. Now let's understand matter. Anything that has mass and occupies space is called matter. For example, water, air, books, wood, and even our body are all made of matter. Matter exists in three physical states. Solid, has a fixed shape and fixed volume. Liquid, has a fixed volume but takes the shape of its container. Gas, has neither a fixed shape nor a fixed volume. These are the three basic states of matter. Now let's discuss the difference between physical change and chemical change. A physical change is a change in which no new substance is formed. Only the size, shape, or state changes. For example, melting of ice, boiling of water. The substance remains the same. On the other hand, a chemical change is a change in which new substance or substances are formed with new properties. Examples include rusting of iron, burning of paper. These changes are usually permanent and cannot be easily reversed. Let's understand the nature of chemical substances. Chemical substances may be elements, compounds, or mixtures. All substances are made up of tiny particles. These particles are continuously moving. There are spaces between the particles, and they attract each other. These basic ideas help us understand the behavior of matter in chemistry. Now we'll study the laws of chemical combination, which explain how elements combine to form compounds. The first law is the law of conservation of mass. This law states that mass can neither be created nor destroyed during a chemical reaction. In other words, total mass of reactants is always equal to the total mass of products. For example, if the reactants weigh 50 grams, then the products will also weigh 50 grams. So, the total mass remains constant throughout the reaction. The second law is the law of definite proportions. According to this law, a pure compound always contains the same elements in the same fixed proportion by mass, no matter where it is found or how it is prepared. For example, water always contains hydrogen and oxygen in the mass ratio of 1:8. That means if there is 1 gram of hydrogen, it will always combine with 8 grams of oxygen to form water. Now let's move to the law of multiple proportions. This law says that when two elements combine to form more than one compound, the masses of one element that combine with a fixed mass of the other element are in the ratio of small whole numbers. For example, carbon and oxygen form two compounds, carbon monoxide, CO, and carbon dioxide, carbon dioxide. For 12 grams of carbon, oxygen combines as 16 grams in CO and 32 grams in carbon dioxide. So, the ratio is 16:32, which simplifies to 1:2. This follows the law of multiple proportions. The fourth law is the law of reciprocal proportions. It states that if two different elements combine separately with a fixed mass of a third element, then the masses in which they combine with each other are either the same or in a simple whole number ratio. This law further supports how elements combine in fixed and predictable proportions. These four laws are the foundation of chemical reactions and are very important for Class 11 exams, NEET and JEE. Next is Dalton's atomic theory. According to Dalton, first, all matter is made up of tiny, indivisible particles called atoms. Second, atoms of the same element are identical in their mass and properties. Third, atoms of different elements have different masses and different properties. Fourth, compounds are formed when atoms of different elements combine in a fixed ratio of small whole numbers. And finally, during a chemical reaction, atoms are not created or destroyed. They are simply rearranged to form new substances. These are the basic postulates of Dalton's atomic theory. Now let's understand the mole concept, one of the most important topics in chemistry. A mole is the amount of substance that contains 6.022 times 10 squared cubed particles. This number is called Avogadro's number. So, remember this important fact, 1 mole is equal to 6.022 times 10 squared cubed particles. The mole is also the SI unit for the amount of substance. Next, let's understand molar mass. Molar mass is simply the mass of 1 mole of a substance, and its unit is grams per mole, gram per mole. To calculate the number of moles, we use the formula, number of moles equals given mass divided by molar mass. Or simply, N equals W, M, where N is the number of moles, W is the given mass, and m is the molar mass. This formula is very important for numerical problems. Now let's move to molar volume. At STP, which means standard temperature and pressure, that is 0 degrees Celsius and 1 atmosphere pressure. 1 mole of any gas occupies 22.4 liters of volume. This value is the same for all ideal gases at STP. So, remember, 1 mole of any gas at STP equals 22.4 liters. Stoichiometry is the calculation of the quantitative relationship between reactants and products in a chemical reaction. In simple words, it tells us how much reactant is needed and how much product will be formed. The steps of stoichiometric calculations are: first, write and balance the chemical equation. Second, convert the given mass of reactant into moles. Third, use the mole ratio from the balanced equation. Fourth, find the moles of the required substance. And finally, convert the moles into the required mass or volume. So, these steps help us solve reaction-based numerical problems easily. Now let us understand some important concentration terms. Molarity, m, is the number of moles of solute divided by the volume of solution in liters. Molality, m, is the number of moles of solute divided by the mass of solvent in kilograms. Normality, n, is the number of gram equivalents divided by the volume of solution in liters. These terms are commonly used in solution chemistry and are very important for exams. Now let us study percentage composition. The percentage composition of an element in a compound is given by mass of that element in the compound divided by molar mass of the compound, multiplied by 100. This tells us how much percentage of a particular element is present in a compound. And remember, the sum of percentage composition of all elements in a compound is always 100%. Now come to the point that is 12. Empirical and molecular formula. Let's begin with empirical formula. The empirical formula is the simplest whole number ratio of atoms of different elements in a compound. For example, if a compound contains carbon, hydrogen, and oxygen in the simplest ratio, that is its empirical formula. Now, the molecular formula represents the actual number of atoms of each element present in one molecule of the compound. The relationship between them is molecular formula equals empirical formula to the power of n, where n equals molar mass divided by empirical formula mass. This formula helps us calculate the molecular formula when the empirical formula and molar mass are known. Now let's understand the limiting reagent. A limiting reagent is the reactant that is completely consumed first during a chemical reaction. Once this reactant is used up, the reaction stops, even if the other reactants are still present. Therefore, the limiting reagent determines the maximum amount of product that can be formed. Next is significant figures, which help us express measurements accurately. Here are the important rules. All non-zero digits are significant. Zeros between non-zero digits are also significant. Leading zeros or zeros before the first non-zero digit are not significant. Trailing zeros are significant only if a decimal point is present. These rules help us report measurements with the correct precision. Finally, let's study dimensional analysis. Dimensional analysis is a method used to check the correctness of equations and calculations. Its basic principle is that the dimensions on the left-hand side and the right-hand side of an equation must be the same. If both sides have the same dimensions, the equation is dimensionally correct. And with this, we have completed Chapter 1. I hope these notes and explanations made the chapter easy to understand. If you found this video helpful, don't forget to like, share, and subscribe to Trickimistry. Thank you for watching.